Welcome. Today we are going to talk about integer exponents. And we need to remember that the following rules apply to numbers with exponents of 0, 1, 2, and 3. So any number except 0 that's raised to the 0 power is always going to be equal to 1. Any number raised to the first power is always going to be equal to itself. So 8 to the first power is going to equal 8 because it means there's only one 8 there. If a number is raised to the second power, we say that it is squared. So 3 to the second power is read as 3 squared. If a number is raised to the third power, we say that number is cubed. So 4 to the third power is read as 4 cubed. Something else to remember is anytime that you have a number that is to a negative exponent, the way to write that as a positive exponent is to take a reciprocal of the base, and our base can be written over 1, so the reciprocal would be 1 over 8, a, and then the negative 2 becomes a positive 2. So we're going to explore the properties of integer exponents, and the first one we have is 3 times 3 times 3 times 3 times 3. The base is going to be 3 because they're all 3's. So there's my base. There are 1, 2, 3, 4, 5 3's, so my exponent is going to be 5. In this example, I have a grouping symbol with 4 3's being multiplied and 1 on the outside. So since my base is 3, so I'm going to have 3 to the 4th power and 3 to the first power because there's only one of them. And all together I have 1, 2, 3, 4, 5 3's, so all together that's going to equal 3 to the 5th power. Remember, this is because they're all the same base. In this example, I have two groupings of one is 3 3's, and the other one is 2 3's. So this will be the base of 3 with an exponent of 3, and this will be a base of 3 and an exponent of 2. Altogether I have 1, 2, 3, 4, 5 3's. So 3 to the third power times 3 to the second power is going to give you 3 to the 5th power. What did you notice about when we were multiplying the two powers with the same base? If you see that if you add the two exponents together, you get the final exponent, then you are correct. So we want to add the exponents when the bases are the same. Okay, so knowing that we did that, 4 plus 1 was 5, 3 plus 2 is 5. If we use that same pattern with this equation, I'd have 5 to the second power times 5 to the 5th power. I'm going to take my 5 to the second power plus my 5th power, and that's 7. So we have, the answer would be 5 to the 7th power. We can also use it with division. If I have 4 to the 5th power divided by 4 to the 3rd power, and if I stretch it all out, I know that I have 5 4's. So 1, 2, 3, 4, 5. And then on the bottom I have 3 4's, 1, 2, 3. Now I can take the time and I can simplify this. The 4's will cancel each other out. One on top, one on the bottom, top, bottom. And all I have left are these two 4's here. So my answer would be 4 to the second power. Did you see a pattern? I had 5 4's and I took 3 away and I came up with 2. So that's the same as subtraction. So we had 5 minus 3. So our answer was going to be 4 to the second power. I can use that rule or that patterning and try to find the answer for this. So if I have 6 to the 8th power and 6 to the 3rd power, knowing that I can subtract my exponents, I get 6 to the 5th power. Sometimes you see them like this, where it looks like it's a power that's being powered up. So we have 5 to the 3rd power to the 2nd power. And so what that means is 5 to the 3rd power is 5 times 5 times 5, and that whole thing is going to be to the 2nd power. What this means is that there's 2 of these. So I'm going to have 5 times 5 times 5 times 5 times 5 times 5. And so altogether, how many 5s did I have? I have 6. When I go back and I look at my exponents, I happen to know that if I multiply those, I'm going to get 6. So if I take 5 to the 3 times 2 power, I get 5 to the 6th power. Using that pattern, what would be the solution for this? 7 to the 2nd power to the 4th power. I would take 7 to the 2 times 4 power, which is 8th power. Therefore, we can come up with some rules. If I have the same base and the exponents, and I'm multiplying, I know that I'm going to be adding my exponents. If I'm dividing and my bases are the same and a is not 0, I know that I am going to be subtracting my exponents. If my base is the same and I have a power to a power, I'm just going to multiply those. So m times n or mn. Okay, that's the end of part 1.